Hi everyone, welcome to this channel, Best Science Brain YouTube channel. Today we're looking at WAEC 2024 live practical on qualitative analysis. For those who are watching us from distant countries, WAEC means West African Examination Council examination, meant for those in final years of secondary school or high school SS3. So today we're going to take a live practical on the specimen provided for their examination for this May June 2024 examination. If you are joining us for the first time on this YouTube, so kindly move on to the channel's name, Best Science Brain. Under it, you see the subscription bell or the subscription icon. Tap on it only once and get subscribed to the channel and follow us as we move on. Then, for those of you that are subscribers, we say thumbs up to you. You guys have been trying. And for those of you that join us in WAEC Specimen Analysis 2023, I know that you have, most of you send up messages that you had outstanding results. So, we share our video to your fellow students, teachers of chemistry and physics. You're also welcome to this YouTube channel. Subscribe and also share the videos to your students. And also, for schools that are private schools or big schools, you can also project our videos on the screen for students to learn and understand how to do this simple experiment. So today we're going to look at qualitative analysis, that is tests for anions and cations, provided for 2024 May June WAEC examination. Also continue, why we say you should subscribe, because you subscribe to the channel, you'll be seeing our video notifications. We'll be having we're going to have the endpoint, going to run the titration experiment in a few days from now. We still run the physics practical experiment. We still run that of NACO. We still teach on this YouTube channel, both for both O-level and A-level work. So this channel is rich, is well packaged. So follow us on this channel, subscribe by clicking on the subscription button or bell only once and get subscribed. Invite your friends as we continue in this channel. So today our main work is on WAEC 2024 qualitative analysis. So we're going to start with the questions right now. So we're going to WAEC 2024 qualitative analysis. So these are our speculative questions. The question number 2 says C is a mixture of two simple inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gas or gases evolved. That's the question. I repeat, C is a mixture of two simple inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gas or gases evolved. We'll now move to question 2AI. Says add 10 cn cube of distilled water to C, stir thoroughly and then filter. Keep both residue and filtrate. Repeat, add 10 cn cube of distilled water to C, stir thoroughly and then filter. Keep both residue and filtrate. So we're going to report our work first, 2AI. We're going to report the experiment. Then after the report, then the test, we're going to go to the observation. So we asked to add 10 cnq of this water to C, stir and filter. Report your work in past tense. When I say C plus, that plus means you're missing water, you're missing C with water, plus 10 cnq of distilled water, comma, stirred and filtered. So that's your experiment. To report what you have, the command says add water to C, stir and filter. Remember, you report in past tense. Stirred means that you have already done it, and then filtered. It's always good that whenever you want to do experiments, you first of all report the experiment before you now carry out the experiment. The test means the experiment. The observation means what you see after you have done the experiment. So when you have a question of this nature, first of all, report your experiment after you report the experiment before you carry out the experiment. Because if you don't report your experiment, you may forget what to write here. So report before you do the experiment. So C plus 10 cm of this water, stirred and filter. It does not matter whether it's 10 cm of this water. Where you can say 5 cm of this water. They can say 7 cm of this water. It does not matter. So whether you're using 5 cm cube, 10 cm cube, or whatever 100 cm of this water, the same answer is what you're going to get. So the amount of water here does not actually matter. Okay? All we know that we're adding water to what? To C. So what I'm holding is C. As you can see, label C, a mixture of two salts, two simple organic salts. And this is distilled water. You're going to add water into C. You are not measuring the amount of water you are adding. Just add a reasonable amount of water into C and then stir. You can use a stirrer. You can as well shake the mixture. I can increase the reaction by shaking, make it more vigorous. That is salt. This is not acid. Don't get afraid. So what do you notice? I'm asking you guys. White what? Solution. Is anything like white solution in chemistry? They're not like white solution in chemistry. White PPT? Okay. But remember that in this we have two what? How many salts? Two. So not only one salt here. Are you following? So this may be misleading. Somebody can say that that C contains a mixture of soluble and insoluble salt. But is that right? You don't know yet. Because since there are two salts, they have to filter. Likely one is what? Soluble. And unlikely one is what? Insoluble. That one you have to filter. But in this case, I will tell you whether they are all soluble or one is what? Soluble, one is what? Insoluble. Are you following it now? So it's more like we're having a kind of insoluble substance. You can look, if you go down, you see that, look at it. The top layer is clearing. And the bottom is getting what? Thicker. Are you following? That means there's some sediment or deposit inside this test tube. So you do it for a while, you're going to have it. Let's see what's going to happen for a while. So as you can see that the top layer is becoming clearer, or a little bit colorless. Then we'll now have white deposit or white plate form under. So in actual sense, there's a reaction between the two salts. The two salts provided here are all soluble. The reaction between the two salts, they reacted to give you a deposit under. That deposit is normally called a precipitate, which is white in color. So it can be misleading that somebody can say that the two salts are that one is soluble and one is insoluble. No, the two salts are soluble, but the two salts underwent precipitation reaction to produce a white deposit. Okay, so let's go to the whiteboard and report our work. Observation: the two salts reacted in the presence of water to produce a white precipitate. How is it? So the reaction is a double decomposition reaction, or what's called precipitation reaction. The two salts that make up C reacted with the water to produce a white precipitate. So the next, we are asked to filter the mixture. So the filter part. To fold your filter part, Learn how to do it. You fold it into a semicircle first. After doing that, you fold it again into a cone. That is fold 2 times. I repeat myself. Do the filter paper, please. You fold it into a semicircle first. When you have done that, you then fold it again into a cone. You see that? So repeat again. Filter paper, a circular material, fold into 2 equal parts, semicircle, fold again into what? A cone, and then hold it here. Then we'll now get our filter funnel. Put it inside. Before we insert it, we're going to insert the paper into it. So there are 2 openings on the paper. You can see one here and one here. Close one and open one. Are you following? One should be closed. You open one of the sides. Then insert it into the filter funnel. So if the pipe is sticking out, it's not well lapped. What you do is this. You can sprinkle some water inside the funnel. That water acts like a kind of adhesive for the paper. Then, like a gum, you can now put it inside again. Okay, you can see that. It's where it has lapped very well. You can now insert it into the test tube. Then take your mixture that you can see it's clear now. You want to filter, shake it very well. So you can have a kind of a uniform mixture. And then what? Filter, pour into this. Allow it to start draining little by little. Pour into it. So make sure that you don't exceed the level of the filter by the funnel, so it don't overflow. So when it drains for a while, you can add more. So still have enough space. You see, it's draining, it's coming down. End of the day, what you collect here is called the filtrate. The white solid the PPT remaining inside is called the residue. So let me still add more water to wash all the remaining. So when you have this, after rinsing, you can empty it into this place. Making sure the level of your mixture does not exceed the level of the filter paper. So you can still rinse more. In the examination, once you have collected enough of the filtrate, but time is what you have the determining factor. When you get enough of the filtrate, or the filtrate, there's an accident, or the filtrate, you don't have to what you have to do, you don't have to continue wasting your time waiting for this to filter all through. When you take enough of the filtrate, the negotiation on the filtrate, what you do is you transfer the filter funnel to under test to continue filtrate. While you continue to do your what? I think there's an error here. Can you see this? So that the filtrate is not what? It's not well done. Are you following? We're going to allow it to filter. Don't be afraid. Allow it to filter. After filtration, what you do, you can refilter this one. Are you following it now? Because the filtration is supposed to be what? Colorless. This white substance should not be entered. That means the filter has an error or have white pots. That's a mistake, an error in the experiment. So when you have this kind of situation, there's a mistake, an error somewhere. So allow everything to go through or filtration to continue. At the end of it all, I'll now refilter this one. Okay? So I'm going to transfer, due to this effect here, I'm going to transfer the filter funnel to this one and then refilter this. So that filtration process will continue in this other second funnel. So I'm going to put this one inside the test tube rack and then refilter this with another filter funnel and another filter paper. Okay? To get what we want. I'm going to refilter the suspension we have earlier. So I'll fold again into 2 equal parts. Fold again into what? A cone. That's under 2 equal parts. You fold 2 times. Then open one part and close the other part. Then insert into the funnel. Then I'll look for a clean test tube. And then I'm going to filter this again with the error encountered. I have to be more careful. This is going little by little. It doesn't matter, I can filter more than once if you're not getting the actual result. But the filtrate should be totally colorless. So it doesn't matter how many times you filter. Sometimes the materials you use may have the filter may not be good. So you can repeat it again and again until you get a colorless filtrate. Okay. So it's going little by little. Then let's look at the other one that we kept standing. You have finished draining. You can see the inside. You have a white what? Residue. Are you following that? The residue. After filtration, the PPT form is now your residue. Are you seeing it? Yeah. So we may not even need all this. So this may be, I may carry on with the remaining filtrate for the experiment. So I may keep this one, not all that necessary. So you know waste some time. Then the residue, you see that is white in color. Come closer. You now open it on the table and allow it to dry. Allow it to dry. Allow it to dry. So that's the residue. So in the process is we are getting a colorless filtrate and a white residue. Colorless filtrate and what? White residue. So this is the filtrate. While the one on paper is the what? Residue. Okay? Alright. Let's go to the board and report our work. So we now add on to what we're written. We say filtrate is colorless and residue is white. Filtrate colorless, residue is white. That's what we got after filtration. Then the inference side will now write C is a mixture of two soluble salts. See the mixture of two soluble salts. Then you now write reaction is double decomposition. Or in brackets you write precipitation reaction. So this is what we can make up from experiment number 1. C is a mixture of two soluble salts. Reaction is double decomposition or precipitation reaction. So after this, we're now going to analyze these 2A. We're going to look at the analysis, why we're having such observation and why we're having such inference. So the analysis of these 2AI. So let's see why we're having such result. C contains two salts. The salts in C are lead nitrate and sodium carbonate. These two salts are soluble salts. The two salts are soluble salts. So if we have this, the equation or the theory part of the practical, we have lead nitrate, sodium carbonate reacting together. When they react, see the compound ionic. We can split them into lead ion, lead 2 ion, and nitrate ion. This one into sodium ion and carbonate ion. So move unlike terms together. Equivalency cancel out. Move this one together. So you now have lead carbonate and then sodium nitrate produce. So this is a product formed when the two of them were mixed with water. But aqueous means presence of water. Then all sodium salts are soluble. So this one is aqueous. So this one, sodium nitrate is the filtrate you obtained. White carbonates are insoluble. Most carbonates, this one is insoluble. So this one is the white precipitate. The lead carbonate is the white precipitate, which came out as the residue. So in actual sense, we didn't miss a soluble salt and insoluble salt. Rather, we missed two soluble salts. And they reacted to produce one soluble, which is the filtrate, and one insoluble. So that means the reaction is what's called double decomposition reaction or precipitation reaction. So that will have such inference on the board that the two salts reacted, so observation, in the presence of water to produce what? A white precipitate. Then the filtrate, which is the sodium nitrate, is colorless. While the residue, which is the lead carbonate, is white. You see, under our inference, C is the mixture of two soluble salts. Reaction is double decomposition or what? Precipitation reaction. So that explains number 2AI. So we move to question 2AII. That says, that is 2AII. Says, test the filtrate with litmus papers. Test the filtrate with litmus papers. So report our work here. Our work going to be filtrate plus litmus papers. We have two kinds of litmus papers, the blue and the red one. So we're going to test filtrate with the blue one and also test with the red one to find out whether it's acidic or whether it's alkaline, whether it's alkaline or whether it's what? Neutral. So that is it. So go to the experiment. We go to the experiment and do it before we report our observation. So this is the filtrate, and that's the blue litmus paper. So we're going to touch it slightly, giving it 2 seconds on the filtrate, and see whether we're going to have an effect. We're going to have an effect on the paper. So the blue paper did not change. So there's no effect on the blue paper. That means it's not acidic. We'll now pick the red one and try again. Any effect? Yeah. We change to blue. So that means this one is what? Alkaline. The filter is alkaline. So we'll go and report our work on the board. Observation, say filtrate have no effect on blue litmus paper, but change red litmus paper to blue. So having done that, our inference is filtrate is what? Alkaline or basic. Don't say that filtrate is a base. Don't say it's an alkaline. Rather say it's basic or you say it is alkaline. Please. So that's the word. Don't say filtrate solution. Filtrate is really a solution. Don't say filtrate solution. That is wrong. So filtrate is already a solution. So the word filtrate means substance dissolved in a liquid. So the word filtrate covers. So make sure the language you use here will tell you what you use in the observation and the inference. And in this kind of exam, you don't score on the test. Your score comes in the observation and the inference. If the observation is wrong, the inference will become wrong, even if it's a right inference. You write a wrong observation, like if I say you change blue paper to red and have no effect on the red one. If I say you change blue to red, and then I come here and write filtrate is alkaline. Actually, filtrate is alkaline. But for it to be alkaline, will you change blue to red? No. It should be you change what? Red to blue. So the observation should tell you the inference. If you have a wrong observation, you're going to fail the inference, whether it's right or wrong. Then if you have a wrong experiment test, you don't report very well. This was a filtrate plus litmus. You can write solution plus litmus. Which solution are you talking about? You can write residue plus, and then write observation and write inference. But you wrote a wrong test, you're going to score 0 on these two sides. So you have to be very careful. Okay. So go to question 2B. 2B says, to 2 CNQ of the filtrate, add 2 cn cube of iron sulfate, followed by slow addition of 1 cn cube of moderately concentrated H2SO4. Repeat. 2b. To 2 cn cube of the filtrate, add 2 cn cube of iron sulfate, followed by slow addition of 1 cn cube of moderately concentrated H2SO4. So before we do the experiment, we have to report our work on the whiteboard. So now I have 2 cn cube of filtrate plus 2 cn cube of iron sulfate aqueous plus again 1 cn cube of concentrated H2SO4 aqueous. So these reagents you are writing, they are in the formula. You must put aqueous on close to them. We'll now move to the experiment and then have observation. So these are filtrates. This is a clean test tube. So 2 cn cube means you collect small amount. You will not measure anything. This is not volumetric analysis, not titration. So you estimate 2 cn cube. Just collect a little amount of the filtrate. What color? The filtrate is colorless. I hope you know that. So we're going to add the iron 2 sulfate. You can see the name, iron sulfate. So we covered it to prevent oxidation of the iron 2 to iron 3. The color is almost changing itself. Look at it. So remove the top, the masking tape, and add some iron 2 sulfate into the filtrate. So now I have it. So what color are we having? Green. We're having green color. Am I right? Yes. So green solution is formed. The color filter change. So we now add moderately concentrated H2SO4. This is the acid concentrated into this. Are you seeing it? You have a kind of brown what? Ring formed. So you have a kind of brown suspension. So this is what we call, you can see the lower end is clear. The brown is what? Hanging. So this is what we call brown ring test for defining NO3. It is clearing. Are you seeing it? So we're now going to, and the brown color is now appearing down somehow, more than up. So that is the brown ring test. What chemical substance is the filtrate made up of? I said it today. It's still on the board. What is the filtrate on the board? Sodium what? Triazole nitrate 5. So that means we are testing for NO3 ion, which is known for its brown ring test. Okay? So go to the board and report our work. So on the test column, we're going to make some changes here. Because when we added the iron sulfate to the filtrate, there was an observation. A green was solution. And when we added the H4, we had under a different observation. So we're going to clean plus 1 cn cube of H2SO4. First of all, report what we observed when we added iron sulfate. So here we say green solution. Or the filtrate turned green. That's writing. The filtrate turned green. So that was what we observed. Then you now come to the next line after this and then say plus 1 cn cube of concentrated H2SO4. Then under observation, now I say a brown ring is formed between the layers of the lipids, of the two lipids. Brown ring formed. So our inference will now write here. The inference should come under addition of H2SO4. That way they are good writing inference. There'll be no inference on that of addition of ion 2 sulfate. Because that green color shows the ion 2 present, the reagent. So we are going to put your observation here. You write NO3, capital N, capital O, then 3, negative, confirmed. NO3 ion confirmed. So that is it. So this is a brown ring to confirm NO3. Remember the filtrate is sodium nitrate. So we are testing for the anion, which is NO3 in the filtrate. To go to question 2CI, that says transfer the residue into a boiling tube and add 5 cl of dilute HCl. Repeat. Transfer the residue into a boiling tube and add 5 centimeter cube of dilute HCl. So we're going to do that now. Before we do that, we're going to record the experiment on the whiteboard. So 2CI report is residue plus dilute HCl, then plus heat. Residue plus dilute HCl and then heat. Although it's not mandatory that you must heat in this experiment, this particular number. Not a must that you're going to heat. So whether you heat or not, you still get the same observation. Go to the experiment now. So we want to transfer the residue into a boiling tube. So scoop it. Either we use a small spoon or use a spatula to transfer the residue into a boiling tube. So we have enough residue, which you got after filtration. Remember, it's white residue, as you are seeing it. Let's collect more on this side. Okay, that'll be enough for the experiment. Okay. So we're adding the acid to the residue, and this is HCl acid. That's the name, HCl. Adding to the acid. Since the residue is on the wall of the flask of the tube, I will slant it before I add. You see something is happening. You observe very well. You see some tiny what? Bubbles. We call that effervescence taking place, the reaction. We add more of the acid. I'll cover this place and heat. So guys, let the gas come out. Where it is now? And the round bottom flask, I have lime water. Look at the residue is boiling. Bubbles are coming forth. So that means the gas is being liberated. We'll call that phenomenon effervescence. So we expect the gas to turn the lime water milky. So you see that effervescence is taking place, the gas is coming out. And look at the lime water. Come closer. The neck of the round bottom flask. The lime water has turned milky. So you see a lot of gas is being even wasted. It's coming out from the test tube. And then the lime water has turned actually milky. So let me show you what I mean. So you come closer. The neck of the round bottom flask is cloudy or milky in color. So which gas is this? Carbon 4 oxide. So you see. So you can still boil further if you wish and collect more gas. But we have this, so you can see this is a lot of process taking place. The gas coming in large abundance or large amount. So we have to heat and allow this to cool. Okay? We can now report our work on the wire. To put our observation should be residue dissolved to give. Or before we go to that observation, the first thing we should write is brisk effervescence occur. Effervescence is that gas liberation in bubbles, liberating a colorless, odorless gas, which turned moist blue litmus pepper, faint red, and lime water milky. So residue dissolved to give a colorless solution. You see? But before we talk about residue dissolved, when we added the HCl, if you notice very well, when we added HCl, it's more like a white solid was formed. So we have to report that out before we talk about dissolved, please. So we have to write on addition of HCl to the residue, a white precipitate PPT was formed. We dissolved on heating to give a colorless solution. So that is it. The other inference, the gas that had this supplementary test is CO2. When I say gas is CO2, then I write under it triose component 4, that is CO3 ion confirmed. Gas is CO2 and then CO3 ion confirmed. So that is it. We'll go to the next question. 2CII says boil the mixture from 2CI and allow to cool. Already done the boiling. So these 2CII say boil the mixture from 2CI. The mixture from 2CI is the residue and HCl. So and allow to cool. So we're going to make some correction there. So 2CII boil the mixture and allow to cool. So already boiled it, and then we're going to observe what will happen when it cools. We can remove the heat here since we are told to boil the mixture. So what we have right here is say 2CI. That means a mixture from what? 2C what? I plus what? Heat and what? Allow to what? To cool. So we can repeat this experiment. The mixture is still with us. We're going to boil the mixture, then see what's going to happen when we boil it, and then allow it to cool. So I hit the mixture from 2CI to boiling point. What we tell you is see that there's not like white paper inside it. So after hitting it, that white solid is what? Gradually what? Dissolving or vanishing. We hit it boiling point. Then observe what happens after heating it, and then allow it to what? Cool, and see what's going to happen. So you see that the white substance has disappeared clearly. It's no longer there. Let me see. If I boil more, see that it's no longer there. The gas is still coming out, the CO2 gas is still coming out. So the white solid has disappeared as we boil the mixture. So we're going to allow it to cool for the next few seconds and then watch again. Okay? So on cooling, the solution is gradually cooling. The mixture is gradually cooling. You are seeing a white what? Deposit. Are you fully coming out again? So when we boil it, the white deposit disappeared or dissolved in hot water. On cooling, it did what? Reappeared. Okay? Which salt is probably present here? Not lead carbonate. Which salt is probably present that dissolves in hot water and reappears on cooling? Lead what? Lead what chloride? Lead 2 chloride. So allow to cool. Mixture from 2Ci plus heat and allow to cool. Right here, white precipitate dissolved on boiling and reappeared on cooling. So our inference should be lead 2 ion from BBCl2 confirmed. So lead 2 ion from BBCl2 confirmed. So that is it. We'll now go to question 2D, alternative to question 2C. That means this question D can come in place of question 2CI and II. The 2D says transfer the residue into a boiling tube and heat strongly. Transfer into a boiling tube and heat strongly. That is 2D, which is alternative question to question 2C. 2D says residue plus heat. So we want to heat residue strongly and then see what will happen. Or heat the residue over the Bunsen burner. So that's 2D can be an alternative question in place of 2CI and II. Or it is also possible that the two of them can come out. Okay, so go to the experiment. The residue, we want to heat it over the Bunsen burner with no reagent inside it. When you observe, you come closer, you see that the gas is coming out, the colorless, odorless gas. That gas is still the same carbon 4 oxide coming out. So you want to test for the gas, as we did before, you connect the gas to a line, to line water. Okay? Connect the gas to line water. So, but we don't have to do it again since we have done it before. We'll heat the residue to see what happens after heating it. There's going to be a color change. Are you observing any color inside it? Yes. What color is that? Brown. The color is not called brown, it's called reddish brown. It's called what? Reddish brown. So we are done. So let's observe very well. Reddish brown color. The gas, the bread is carbon 4 oxide. So the gas is still coming out like smoke. Colorless and odorless. So we'll go to the board. So observation, you say residue decomposes, liberating a colorless, odorless gas, which turned moist red, moist blue, litmus, pepper, pent red, and what? Lime water milky. I did not do this experiment because I've already done it before. It's the same CO2. Then a red, reddish brown deposit was obtained after heating. Sometimes you can still get a yellow deposit. You get a yellow deposit if the salt you're heating is a pure compound. If the compound is not all that pure, you have reddish brown. So whether you write reddish brown deposit or you have yellow deposit is still correct. So now right here, gas is CO2, CO32 minus confirmed. Then reddish brown deposit, which after heating, deposit is nothing but lead 2 oxide, You see, that is it. So we have come to the end of this experiment, qualitative analysis, alternative A for WAEC examination 2024, WAEC examination, alternative A practical. So we are justifying the experiment as a student. Go through the video, subscribe to the channel. If you're not subscribed, tap on the channel's button or the bell and get subscribed. Share the video to your friends and then invite your friends to the channel, Best Science Brain YouTube channel. Best Science Brain, that is YouTube channel. And then go through the experiment and say, as you do it in school, you still confirm the same result, the same observation, and the same inference. So as you go on, if you're a subscriber, you have a lot of benefit. You're going to see how the titration, the endpoint determined on this YouTube channel. And also, we're going to still do alternative B. B, that is practical chemistry B, and also A and B of physics. So stay connected to the channel. Thank you for listening.